Welcome, my name is Terry Soul, and this is Programming Chaos, a channel devoted to fun and interesting programming projects to help you hone your programming skills. For the new year, I want to do something a little different. This is a video really for beginners. I'm going to walk through setting up the processing programming environment, which is the one I tend to use for most of these videos, and do a couple of starter programs. So if you're brand new to programming, hopefully this is the video for you. The first thing we need if we want to learn to program is an environment to program in. And as I said, I'm going to be using processing, which I think is a fantastic environment, not only for beginner programmers, but also for more experienced programmers who want to try out different ideas. That's where most of my videos are. So in order to get started, we need to install processing, which is a simple process. Begin by pulling up whatever web browser you happen to prefer, and simply go to processing.org. So here we are, and from here we can just go to download, and I'm going to download for Windows. There are other versions if you need a different version. Oh, and of course I actually downloaded it twice, which is pretty typical for me. Let's go ahead and open up that folder. I'm going to close my window here, and what we get, I'll drag it onto the desktop, is a zipped folder. So this is the processing zipped folder, and all we have to do is go in and extract everything from it. And all my windows are showing up over there. So show extracted files when complete, might as well. And this is going to take a little while, so we'll speed things up here. So there we go. That should give you a folder with processing in it, and we can open that up and run processing. So I want to be clear here. If you want to follow along with the rest of the video, please feel free to pause it in order to go to processing, click on the download the version you need, either Windows or Mac or Linux, or if you happen to be programming Raspberry Pis, download it. You'll get a zipped file, unzip it, and now we can actually start processing. So we'll fire it up. There we go. And what you'll see is a little welcome message, which I'm going to skip for now, and the first programming environment. So this is the processing programming environment. You'll notice in the corner here, we're doing it in Java. There are some other options which we won't worry about, but they are available if you're interested. And so here is our programming window. I'm going to make it a little larger. And for every processing project, there's a couple of things we need to start with. The first is a setup function, which looks like this. This is what's known as a function. The name of the function is setup, and there's some syntax here which looks a little odd. Void says that this function doesn't return a value. Some functions can give you an answer back. Setup doesn't do that, so we put a void there. Some functions you can give data to, and we'll see examples of this in just a minute. Setup doesn't do that, so we've got nothing there. And then the curly braces just say when setup begins and ends. And all of these features are common to lots of modern programming languages. They tend to borrow each other's syntax. So if you used some other programming languages other than Java, this may look pretty familiar already. The first thing we need is to create a window. And we do that by telling processing the size of the window we want. For me, 800 by 1000 tends to work pretty well. And so now we have a program that I can actually run. Let's make this a little smaller. I click on the run button, and once again, gave me my window on the wrong screen. So let me do that again. There we go. There is my 800 by 1000 window that size generated for me. So there's our first program. Easy enough. Notice that size is also a function. So I said setup is a function. Size is a function that somebody else wrote for me, and I just have to give it the information it needs. In this case, the size of the window that I want. And we're going to be using functions quite a bit. A function really is just, as you can sort of see, a block of code with a starting point and an ending point and some instructions inside of it. And we will write some of our own functions, like setup is a function that we wrote, And we'll use other people's functions. So size is a function that somebody else wrote. The people who created processing wrote it for us. So there's our first program. If I want to save it, which is always a good idea, there's a file menu. I'll go to save as. Once again, shows up on the wrong place, and I'll just put in first sketch. Processing often refers to itself as a sketch language, and you'll notice the default name was sketch. So it's not necessarily meant for creating commercial grade software. You could, but there are other better tools for it. It's more for sketching out ideas, trying things out, and that makes it a fantastic environment, as I said, for learning. There's our setup function. The next function we typically want is a draw function. And once again, we've got this weird syntax of void and some parentheses and some curly braces. And the way that processing works, setup is run once, and it does things like creates a window for me. And draw is run repeatedly. So it keeps updating that window. Anything we want to appear in the window, we can put into the draw. So we have our window. Let me run this. Nothing is being drawn yet. And what I want to do is draw a circle. So we can start to think about, well, how might I do that? The answer is I'm going to call a function called circle, which again, the people who created processing wrote for us. But for the program to draw a circle, we have to tell it where to draw it and things like how big it should be. So I'm going to tell it to draw a circle at 0, 0 and make it size 100. Now, a good question to ask yourself before I run this code is, well, what is that actually going to look like? Where is that circle going to appear and how big is it going to be? What do those numbers really mean? Well, let's run it and find out. What we get is a circle up here in the corner. So that tells me one thing, 0, 0 is actually the upper left-hand corner. So if you are mathematically inclined, you might have been thinking, well, 0, 0 is going to be in the middle, and Cartesian coordinate system, positive numbers are up and to the left, and negative numbers are down and to the right. Turns out that's not the way processing works. And in fact, lots of programming languages don't work that way. They put 0, 0 in the corner, and then positive x values, so we are using a Cartesian system, are to the right, and positive y values are down, oddly enough. So if I were to change this to say 100, a larger y value, now I get a circle that's drawn lower on the screen. So we've already learned a bit. We can draw circles. We know where they're located. We know a little bit about the size. So this turns out to be the diameter of the circle in pixels. So we get not a huge circle by doing size 100, and that's relative to the size, if you want to think about it this way, of the window. My window is 800 wide, 100 wide is 1/8 of that. So I can put a circle sort of anywhere I want in the window and any size I want just by controlling these numbers. And that, in many ways, is the basics of programming. It's using commands that are parameterized with numbers in order to tell the computer exactly what you want it to do. So let's move my circle. I'm going to make it look a little bit like a sun. So let's move it over a bit, 200 and maybe down a little more. And there we go. Looks a little bit like a sun in the sky. Of course, it's white, so I would like to change the color to something yellowish. The way we do that in processing is to tell it what fill color we want. So the command is actually just fill, and colors are defined in terms of red, green, and blue. So if I want a yellowish color, what I end up needing is a lot of red. Our color scales go from 0 to 255 for reasons that we don't need to worry about for now, but 255 basically means lots and lots of red. I'll put in a 223, so quite a bit of green and no blue, and that is my fill color. And if I run this now, there we get sort of a nice yellowish looking sun. So what else can I do? Well, I'm going to draw a little bit of a scene here. So we've got a circle. Let's put in maybe some grass at the bottom. So for that, I'm just going to do another shape, basically a rectangle that fills the bottom of the screen. So turns out the command is rect for a rectangle. And again, this is a function that was written for us to use. We have to ask the question, well, how do you define a rectangle? For a circle, maybe pretty straightforward. You say, here's where the center is, here's the diameter of the circle. For a rectangle, there are different ways to do it, but the default for processing is to define the upper left-hand corner and then the width and the height of the rectangle. So if I want a rectangle near the bottom of the screen, I know my window is 1,000 large, so I want to start all the way over here on the left. So that's a 0 for the X. And for the Y, I want to start down near the bottom. Let's do, say, 800. And then I want it to fill the whole screen. So I want it to be 800 wide. And I want it to fill to the bottom of the screen. So I want it to go from 800 down to 1,000. And let's go ahead and fill that in. That's going to be 200. So that will give me a rectangle. And if I run this, what you'll notice is that rectangle is also yellow, sort of our sun color, because once you give a fill command, everything drawn after that gets the same color. And I don't really want this to be in yellow. I want it to be in green. So I'll go in and give it a different fill. In this case, I want it to be green. So no red, lots of green, no blue. There we go. I've got a sun, I've got some grass. Not the most exciting picture, but it gets us started. And this is sort of the basics for learning to program. You learn some functions like fill and circle and rectangle, and then you try out and see what you can do with them. So I'd like to modify this a little bit. I think my grass is a little too high, so I want to move it down. The other thing that I'm doing here is I'm using a lot of absolute numbers, which are based on the size of the window. And that's going to cause some problems if I change the size of the window. So let's say I make this window a little bigger. So I made it a little taller and notice that my grass doesn't go all the way to the bottom anymore. I've got some gray here. Or if I were to make it a little wider, my grass ends too soon. So now my grass is sort of hovering in midair. And that's because I used absolute numbers, what are sometimes referred to as magic numbers. Like, why 800? It seems like kind of a magic number. It doesn't mean anything. It's just an 800. What we really want to do is use numbers that are relative to something that already exists, like the size of the window. And I'm going to put these back to where they were before. So rather than putting in 800 here, which was the bottom of the window minus a little bit, a better thing to do is to say I want the height of the window, which is 1,000, minus a bit, say minus 100. So that'll go all the way to the bottom and then go up 100. And similarly, instead of saying I want to go 800 because I know that's the width of the window, I'll put in use the width of the window. So no matter how wide the window is, I want my rectangle to be that wide. And then the last thing, because I'm subtracting 100 from the height, I want my rectangle to be 100 high. So now when I run this, we get our nice grass at the bottom. Looks good. But if I make the window a little wider, it's still as wide as the window, because rather than using 800 here, I'm using the width. So whatever the width of the window I created is, that is the width of my rectangle. In this case, width and height are what are known as variables. They're a name for a number. People often think of them as a named box. So you can imagine there's a box called height, and inside is, in this case, the number 1,000. It's not always the best analogy, but it's not a bad one. And so anytime I want to refer to the width of the window, I can use the variable width. Anytime I want to refer to the height of the window, I can use the variable height. And I'm going to put this back to 800 just because it fits my screen a little better. So often we can do a better job with programming if instead of using absolute numbers, we use variables. And it turns out we can create our own variables if we want. So for example, for the sun, instead of saying it is a width of 100, I could create a variable of my own the width of the sun. And let me talk a little bit about how this is done. The name of the variable is here, and I can make up pretty much whatever I want. There are some rules. We won't worry about those for now. I have to tell processing, or in this case, Java, the language I'm using, the type of that variable. So I'm using the word float here to say, this is a floating point variable, which means it can have a decimal. I'm not using a decimal, but it's often good to use float as your variable type in case you need a decimal. And there are other variable types. We won't worry about them in this video. And then I'm using equals to give it a value. And so now I can come down here and say, instead of 100, I want that to be the width of the sun. And notice that my program doesn't really change at all. I still get a sun of exactly the same size in exactly the same location. But what it does allow me to do is if, for example, I want the sun to be exactly one width down from the top of the screen, I could use that variable here. And now the center of the sun is exactly one diameter down from the top of the screen. I used width. It probably would have been better to call that the diameter, which is really what we're talking about in terms of circles. And if I want the sun to be further down, turns out we can just put in some math. So I could do it 2 times that width. And now we get the sun a little lower. So variables are nice because we can use them to name particular values and then use those values in different ways. And from here, maybe I'll build on my scene just a little bit more. I've got some grass. Let's put in a little rectangle for a building. So I want a rectangle. Let's say I want my rectangle to be perfectly centered right in the middle here. Well, I'm going to want to use the width, but the width takes me right to the middle of the screen, and I want my rectangle to be centered. So I need to move a little to the left and a little to the right. So I'm going to begin by putting in some constants. So let's do width minus 50. So that will take me to the middle of the screen and then to the left 50. And for height, I want the height of the window. And then I want it to be at the grass level. So that's minus 100. But then I want it to be a little taller than that. So let's go another minus 100. Now this is an odd way to program it. It's perfectly fine to do it this way. And this is clearly how I thought about it. But now that I've done minus 100, I might want to simplify that to minus 200. It's worth noting people often talk about how computer science depends a lot on math. And that is absolutely true. The thing that's a little misleading is a lot of computer science depends on fairly simple math. So right here, we're doing a little bit of multiplication. We're doing some addition and subtraction. We're certainly using a Cartesian coordinate system, although it's arranged in an odd way. A lot of the math that you need to use in programming and in computer science turns out to be fairly simple, but it helps a lot to be really comfortable with it, to be able to sort of think in terms of, well, I want to go to the height of the screen, minus 100 to get above the grass, and then minus another 100 is where I want the top of my building to be. But there we go. That's the location. And if I went 50 to the left, I want to go a full distance of 100 so that I have 50 on the left of the screen and 50 on the right. So I want my width to be 100 and my height to be 100 as well, because I went an extra 100 above the grass. So if I do that, what I get is a little square, and as you can see, I did this wrong, which is fine. That happens a lot, because I kept talking about the width. Well, this is the width of the screen, so my square is centered right over here on the width of the screen. What I really wanted was half the width. I wanted the middle of the screen. No problem. I'll put in my times 0.5. There we go. Now I have a rectangle, or a square in this case, in the middle of the screen. This is perfectly common to do in programming. You make a mistake, things aren't quite where you expect them to be. You go back, look at where that mistake came in, try it again. Okay, and so in this case, though, that's an odd color, so let's fill it in with a different color here. I want this to be sort of a darkish gray, and so there's 2 ways that I can get a dark gray. One is just to use the same level of each color. And I'm using a fairly small value, 100, so that gives me a fairly dark gray. It turns out in processing, if you just fill in one number, you automatically get a grayscale. So this gives me the exact same gray. And if I want it a little darker than that, do 50. That's quite a bit darker. If I do 0, that's basically no color. I get a total black color. So you can adjust the colors how you want. And just like I used a variable for the sun, it would be a good idea maybe to use a variable for the size of, I'm calling this a building, although it's clearly just a square. So I can make another variable, building width, and let's make this 200, for example. So I'm getting a little bit of an error message here, which says I'm not using that variable yet, which is absolutely true. And I'm going to start using it down here. So instead of -50, I want to go the middle of the screen and subtract from that actually half of my building width. So 0.5 times building width. And then I want the width of the building to not be 100 anymore. I want to use the building width. And let's see, I'm getting another error message. It shows up down here, and that's because, surprise, I misspelled building. So as you program, you will occasionally get error messages, and they can be helpful in terms of finding mistakes. So there, now I've got a wide building, or if I want, I can make a very narrow building. This again is the advantage of variables. If you set up the code correctly, I'm using the width to decide where the building should go, and I'm using the width to define the width of the building, it gives you more control over your programs. Because instead of having to go in and fiddle with several numbers, I only have to change one at a time. So let's make this a little wider. I don't know, I'll do 70. So this gives us a very simple image. I'm just sort of drawing something by using primitive shapes like circles and rectangles. What if we want to animate our image? So for example, I want to have the sun move across the sky. Well, again, the key there is using variables. So what I would like when I go to draw the sun is the X value to change over time. So this is the X position of the sun, and if I want the sun to move across the screen, I need that value to change. So what I really want to do here is something like put in an X, and then have the X increase every time I go through the draw loop. And so I can do that by saying X equals X plus 1. So this will draw a circle at a location, and then the next time it will change the location and draw the sun at a new location. Now I'm getting an error here because X doesn't exist. So I have to create my X value. And if you're mathematically inclined, this instruction might drive you up the wall. Because if you think of this as an algebraic expression, it makes absolutely no sense whatsoever, right? You can't have an algebraic expression where X is equal to X plus 1. The equals operator is not an algebraic equals. It's technically what's known as an assignment operator. We are taking this value and assigning it to X. And I don't think anybody had any trouble with it when I wrote it like that. Didn't really think about it much, but when I write it like this, it suddenly looks weird. There are some programming languages that use like a different instruction here, like a little arrow, so that you're saying, take the value and assign it to X. It's not saying that X is equal to that algebraically. Other programming languages will use the word let or set the value of X. Lots of them, though, use an equals, and ends up looking a little odd mathematically speaking, but from a programming perspective, it's fine. So now the other thing I need to do is, because I'm getting an error message, I need to create X. And so what we might be tempted to do is create it here. And I'll start it at 0, which puts the sun off to the left. There's a problem with this. It won't work. And if I run it, you'll see why. My sun starts all the way on the left the way I want it to, but it's not moving. And technically that isn't quite true. It's kind of moving 1, but then it keeps getting reset back to 0 each time. So every time it keeps getting drawn at the 0 location. So to fix that, I'm going to take this instruction, delete it from there, and I'm going to put it at the beginning of my code. So this turns X into what's known as a global variable. So we've talked about variables. Sun width is a variable. It's what's known as local. It only exists within this function because it was created within these curly brackets. On the other hand, X was created outside of any curly brackets, so it is global. It exists everywhere in the code, and in particular, it exists here and it exists here. And so as I go through the code each time, I'm going to draw my sun, and then I'm going to change the location. So if we run this, now we have a sun that moves across the sky and leaves a trail in the process. So that we probably want to fix. And the way we fix it is simply by redrawing the whole scene each time, basically erasing the background. And it turns out the command to do that is indeed background. The default background color is a light gray, this 200. So now we have a sun moving nicely across the sky, and really the whole scene is being erased with this gray color, which is the background, and then being redrawn. Okay, as long as we're doing the background, we might as well make it a nicer color. So this is grayscale. If I want to do it as a color, we've got red, green, blue. So I probably don't want much red in my sky, and I don't want much green, but I do want quite a bit of blue. So now I have a bluish sky. That's kind of dark. Let's turn up the blue. It's still maybe a little darker than we want. And if you want to fix that, what we can do is add some red and green as well. Now we get a much lighter sky because there's a lot of blue, but there's also some red and some green, which lightens the whole color. And I will say right up front, color theory is not my strong point. This is a good place to go find, for example, a color wheel online and pick the colors that you want. Okay? But there, we've got a nice little scene. Not only do we have some fixed elements like grass and a little house, at least the start of a house, we've also got some animation going on. And notice the way we achieve the animation, and this is typical for animation, we keep redrawing the same object, but at a slightly different location each time. And from here, there's a whole bunch of things that you can do. You can add a bunch more shapes to add a roof to the house, and maybe by doing some rectangles and circles, you can draw a little tree. You could put in some clouds that are grayish colors because we talked about gray, and have them move. So lots of things that you can do just with this sort of starter project. And to help you out a bit, if we go in fact to the help menu up here, I haven't talked about the menus too much. There is an online reference. So let's pull that up here for just a minute. There we go. And this gives you all of the basic instructions that you can use in processing. So it starts with different types of data, which we haven't talked about. We'll want to skip over all of that. Lots on input, a little bit on the keyboard and mouse. I'll do a mouse example here in a minute. But what to begin with might be interesting is to look here at the 2D primitives. So we've used a circle and we've used a rectangle, but notice there are lots of other shapes. You can do an ellipse, you can draw an arc, you can draw a quadrilateral, you can draw a square or a triangle. Let's take a look, for example, at the triangle. If you want to put in a roof on your house, the size is, again, the size of the window, and then they give you a nice example. And maybe not surprisingly, to draw a triangle, you have to give it 6 values, the XY position of each of the 3 vertices of your triangle. And so there's a nice example with what the output looks like, and then some instructions about how it works. So X1, that first input, is the X coordinate of the first point, and the second value is the Y coordinate of the first point, and so forth. So one of the nice things about processing is that it has this sort of handy online documentation that talks about how each of the functions works in a lot of detail. It gives an example to work from, talks about the syntax, And then it'll also talk about related functions. So there are often other things that can be helpful to use. So there's all of our 2D primitives. You can draw lines and points and so on and so forth to add to our little picture. You can do curves. There is a 3D environment, which I won't get into in this video. There's a bunch of math. We'll talk a little bit about math here in a minute. Can generate some random numbers, talk about that as well. So all of this is helpful if you just want to go and look up how different things work in processing. And again, just to be clear, that's under help. Just go to the reference. As long as I'm here, another nice feature of processing is there are lots of examples. So if you go to File, there's the examples, and they're divided into different folders. So for example, we can look at the basics of, say, dealing with images, and there's a whole bunch of sample code for dealing with different images. You want to know more about color? Here's a whole bunch of different example programs that explore how color works. And so another nice advantage of the processing environment is it comes built in with all of these examples that you can look through. A lot of them are more complicated than mine. Okay, so got a little time left. Let's do one more project here. So what I'm going to do is comment all of this out. And so what you'll notice is I'm putting in a slash followed by an asterisk, and then down here an asterisk followed by a slash. That turns all of this into one giant comment. Comments are things that the program, the computer, actually ignores. So they're often useful for doing exactly what their name implies, adding a comment. So I could put in a little comment here. This code draws a scene. Or, as what I'm doing here, taking some code that I might want to use later, but hiding it for now. And so that's what I'm basically doing. I want to keep it in case I want to reuse it, or if you want to keep looking at it, but I don't want it to actually run. And so I'm putting it into a comment. What I want to do is one more little project. So I want to draw some circles, but I'm going to use two other variables that are built in. And those are the location of the mouse. So I've got this mouse pointer moving around. It turns out I can just ask for it. It's the mouse X and the mouse Y location. And so I'm going to draw a circle wherever the mouse is. One of the things you'll notice, I should have mentioned this earlier, is built-in variables like height and width or mouse X and mouse Y are in pink so that you know that they are built in and they already exist. And then I'm going to go ahead and put in a size for my circle. There's my window, and now it draws a circle wherever the mouse is, which is kind of fun. Looks a little bit 3D. It's not really 3D, but kind of fakes it. And not much to the code, right? It's just, I know where the mouse is. I want to draw a circle there. Of course, this circle is white. That's kind of boring. Let's put in some color. So I'll come over here and say, well, I want to do fill. So I could fill in with whatever color I want. We could do, for example, a bright red circle. There we go. One thing you'll notice is the first one is always done in the corner. That's sort of our 0, 0. There are ways to fix that. I won't worry about it for now. Kind of interesting, but we can get a little fancier by instead picking random colors. So another built-in function is random, and that returns a value in a particular range. So I can say I want a random color from 0 to 255, a random amount of red. I want a random amount of green, and a random amount of blue. And one of the things I'm doing here, which is worth mentioning, is fill is a function. It expects to get 3 values, or 1 value if I'm doing grayscale, but I'm doing colors, so 3 values. But instead of giving it a value, I'm calling another function. And so the way this works is I call the random function, which is again a block of code somebody else wrote for me. I tell that function, I want a number between 0 and 255, and that function runs some code and gives me back a value between 0 and 255, and then that gets plugged in here. So in a sense, this all gets replaced by a number, which is what Phil wants, right? Our Phil wants to get a number. And so we generate our 3 random numbers, and Phil then uses them to pick the color. The key here is that every time I go through the draw loop, it's going to repick a new random number. And so when I run this code, I get a new random color every time. And if I stop, it's still looping. It's still drawing those circles over and over and over again. And so you can see my circle keeps changing color because it keeps drawing on top of itself. It's basically piling up a whole bunch of circles there of different colors. And we can move around nicely. And there we go. And so let's do one more thing as long as we're here. Let's play around with the size of my circles. So I just set it as a default of 40, but I'm going to change that a little bit. And I'm going to change it not randomly, because randomly would be pretty noisy. I'm going to use a sine function. So this is going back to trigonometry. Hopefully you've done a little trig. If not, a sine function is a function that basically gives you a nice smooth wave, a sine wave. And so the value goes up and down as we move across. As x increases, or as the input to the sine increases, the value of the sine oscillates. And the sine function by default is from 1 to -1, which is not very big. So I'm going to multiply it to get a bigger range. So basically I'm taking a little sine wave, just goes from 1 to -1, and multiplying it by 30. So now it'll go from -30 to 30. And then I have to give it a value. And I'm going to put in another built-in variable. So every time we go through the draw loop, we draw a new frame of our window. And processing keeps track of the frame number. It's called the frame count. And so as time goes on, the frame count increases. That will become my input to the sine. It turns out the frame count goes up pretty high. So I'm going to multiply that. Actually, let's do it by 0.01. So what this does is it takes a sine wave that normally would be this very fast small up and down. I multiply it by 30 to make it bigger. And then I take my frame count and multiply it by 0.01, which stretches it out. So I get this long, large stretch sine wave for the size of my circle. And if I run this, okay, there it gets smaller. And then it starts getting bigger again. And that's as my sine wave changes. And that's actually a little slower than I wanted, not uncommon. So let's go back and try making this 0.1. Well, maybe that was faster than I wanted, but that's not too bad. So there, that's actually the sort of weird 60s vibe that I had in my background. So the key here is that I'm playing around a little bit with some random numbers to get random colors, and then some different mathematical functions in order to get those changes in size. And I suppose if I wanted, I can make this a bit bigger and make this a bit bigger. You'll notice these two are tied together because sine goes down to -1. So this is going to be -70. 80 minus 70 is 10. That's going to be my smallest circle is going to be 10. My biggest circle, sine goes up to 1, so this goes up to 70. My biggest circle is going to be 150. There's our sort of simple math to understand what's going on the screen. So big to little circles. And now maybe because that change is so big, like, that's changing a little too fast. We could slow this down a bit. There we go. Some nice interesting patterns to draw if you want. The key here to keep in mind is that because we're dealing with computers, I'm controlling all of this with numbers, right? It's how much do I take the current frame count and multiply that by in order to determine how things go on this move on the screen? Or if we go back to our old scene, it's how do I handle the building width in order to make my building show up in the right place? So there, in a sense, is two, if you will, starter programs to work from, and you can go in and start playing with these. What if, you only randomize one of these, so only the red is randomized? What if instead of circles you draw rectangles or ellipses or triangles? What if you take the scene and, as I said, add a roof? What if you combine these two so you have a scene that you can draw on? That is a lot of learning to program, is saying, well, I have a basic program to start from. What can I do with it? How can I change it? And that's really how you learn more about a programming language, is trying to push it, right? Trying to push the boundaries of what you can do. Okay, thank you and happy programming.